All right, here's the 5.1 homework. See, it's not too long. It's got, what, 5 or 6 problems, something like that. There they are. And you will see problems that are both confidence interval and hypothesis testing. So you'll be using both the t-interval and t-test functions in your calculator on this homework assignment. So for this first one, I mean, you can read through the whole thing if you want, but I think pretty quickly you'll realize that what they're asking for here is a confidence interval. Looks like they want a 90% confidence interval. And if you're going to make a 90% confidence interval, you need to know x bar, so the sample average. It looks like they're giving that up here. And then the sample standard deviation, that's important. This 1.3 is S, not sigma. If you read this really carefully, this 1.3 is just referring to these 43 cookies, not all cookies out there. So that's an important fact to keep note of when you're reading through this. They're giving you S, X bar, your level of confidence, and N. And so if you go to stat and then tests and select T interval, you'll see that that's the function that asks for exactly that stuff if you tell it you have statistics about the data, X bar, S, N, and your confidence level. This will spit out two numbers. You put in those numbers here. Apparently they want them report accurate to 1 decimal place. Sure. Question 2. Same idea, except now instead of giving you statistics about the data, they give you the data itself. So now when you go to the t-interval function in your calculator, instead of telling it you got statistics, you tell it you got data. It'll be like, where is that data? Well, it's up to you to put this into a list and then tell it what list you put it into. But basically the same idea. It'll give you a confidence interval. Note that we're estimating mu, the population average here. I don't know that you get much out of putting that in there, but I guess it's not bad to remind you of that fact. That's the idea with question 2. Question 3. This is another one. I kind of like this question. It gets into a little bit more theoretical stuff. So it's data again. I try not to give you too many of these data questions, but I think in this case it's worth doing. They give you these observations, so you type these into another list, and then your point estimate. It'd be nice if you knew what your point estimate is. Your point estimate is always your sample average. And you're like, oh man, I got to calculate the sample average of this data. I have to do one variable statistics also. No, you don't. When you make your confidence interval until you have it the data, it gives you not only the bounds of your interval, but it also spits out X bar, the sample average. So it gives you your point estimate, and then it asks which distribution should you use. Essentially, you're just making note that it's a t-distribution as opposed to a z or normal distribution. And that's because it doesn't say you somehow know the standard deviation of the population is something. The only standard deviation you have in the problem is the one that you calculated from this sample data. It's S and not sigma, so it's a t and not z distribution. And then this one, what must be true in order to construct a confidence interval in this situation? So again, I told you that I'm not going to ask you about shape, center, spread. But if you were thinking about the shape of this guy, well, let's see, it's a t distribution because, as opposed to a z distribution, because sigma is unknown and I instead have S. But I still need either my sample size n to be greater than or equal to 30 or my parent distribution to be approximately normal. All right, so up here, my sample size is only 11. It's not greater than or equal to 30. So it must be the case that the parent distribution is normal. So what must be true? The population standard deviation must be known. No, that would give me a z interval, completely different. The sample size must be greater than 30. No, it can't be greater than 30. The sample size up here is just 11. The population mean must be known. No, if you knew the population mean, you wouldn't be creating a confidence interval for the population mean. It would be dumb to estimate something that you already know. The population must be approximately normal. There we go. We're getting on that one. I don't know. I feel like it's a good theoretical question, but I just told you the answer to it, so maybe you don't get anything out of it now. Construct a 90% confidence interval. That's just these two numbers that come out of here. Although note that typically they give you two different boxes to type the two different answers in. In this case, they want it as an open interval. So you'll type parentheses, some number, comma, some other number, close parentheses. So use this format with the parentheses and the comma in between. Otherwise, it won't understand what you're getting at. And then what does it mean to be 90% confident? You can figure out which of these conclusions are the ones that we've been writing in the videos. And then these two, I don't know. I think they're interesting, but it's not something I'd ever test you on. What they're going to do here is you're going to make your confidence interval, and I think what you'll find is 2 hours is not within your confidence interval. So maybe you make your confidence interval for this, and it goes from 2.1 up to 2.7 or something. I don't know what the actual numbers are, but suppose 2.1 to 2.7. Is it possible that the population mean is 2? Your confidence interval went from 2.1 to 2.7. Is it possible the population mean is 2? Well, yeah, it's possible. It's just not very likely, right? Because I am, where's my level of confidence? 90% sure that the population mean is in between whichever two numbers you put here and here. And I think you'll find that 2 is not in between those two numbers. Anyways, it is possible, but no, it's not very likely because we have 90% certainty. Cool. So the first 3, you're dealing with confidence intervals. The next 3, if I remember right, you deal with hypothesis testing. So same idea here. They give you the null and alternative, sample size, mean. And if you note really carefully here, the standard deviation is S and not sigma. Probably didn't even notice it, but if you go back to your 4.3 homework assignments, they look a lot like this format, except the standard deviation they'll give you is sigma, because you're supposed to be doing a z-test then. If it's S, it's a t-test. Test statistic and p-value. Oh, nice. It's set up for the p-value method of hypothesis testing. That's good, because I told you won't be doing the classical method in this class because not everybody has the inverse t function on their calculator. Question 5, same idea. You're still doing hypothesis testing, except now you got sample data instead of statistics about the data. Right? So on this one, you're choosing t-test and telling it to have statistics. In this one, you'll type these numbers into a list, choose t-test, and tell it you have the data itself. But again, it's the p-value method you can see it set up for here, test statistic and p-value. You can answer the question. And then finally, here's a question on type 1 and type 2 errors. So they give you this situation right here. And in this version, they ask you what a type 2 error would mean in this context. So watch that video on what a type 2 error is, and hopefully one of these 4 would be your answer. And this is the type of question I will ask you on quizzes about type 1 and type 2 errors. I will do some problem, you'll work all the way through it, and then there'll be like a step D at the end, where I say, what would a type 1 error be in the context of this problem? Or what would a type 2 error be in the context of this problem? So make sure you can state it like whatever the correct answer is. And that's this homework assignment.